Today we'll be starting with a new chapter, sound. Let us first listen to a wonderful song. What do you mean by sound? Sound is a form of energy. It is a kind of mechanical wave which needs a material medium like air, water, steel, etc. for its propagation. Propagation means movement of sound. And sound can propagate through solid, liquid and gas. We can describe a sound wave by its frequency, wavelength and velocity, and we'll be learning about it later. The sound wave is a kind of longitudinal wave or mechanical wave. That means the particles of the medium vibrate in the direction parallel to the direction of propagation of wave. What are the three essential conditions for the sound to be heard? A sound is always produced by a kind of vibration. It always needs a material medium for its propagation, and it needs a receiver to receive the sound. The learning outcome of this particular lesson is, at the end of the class, the students will be able to identify sound as a form of energy. They will be able to differentiate between longitudinal wave and transverse wave. They will be able to identify sound wave as longitudinal wave. They will understand the phenomenon that sound is produced by any kind of vibration. They will verify experimentally that sound needs a material medium for its propagation, and they will experience through animation the propagation of sound. Sound is always produced by vibration. If you copy this link and paste it in the browser, you will see an activity which will confirm this fact. In the figure, several instruments are shown which is producing sound. The first one is a drum. Beating of drum is an example of production of sound where the membrane of the drum vibrates to produce sound. It is true for all percussion instruments like tabla, dholak or any other percussion instrument. Similarly, in the second figure we can see one guitar. All the string instruments like guitar, sitar, veena and all, sound is produced in these instruments by the vibration of string. The third one is a tuning fork where the vibration of prong produces sound. One activity is shown below where two pencils are stuck to a plastic pencil box with a rubber band, and when the rubber band is plucked, sound is produced. In the third figure we can see one bowl which is filled with water and some tuning forks are kept. When the tuning forks are hit by a hammer and immediately the prong of the fork is touched with water surface, the water starts spilling up. So this proves that sound is produced by vibration. Here is an activity to prove that sound can't travel without a material medium. You can go to the link and you can see a kind of simulation of this experiment. In this experiment, we have one glass bell jar, we have one electric bell, some connecting wires and a vacuum pump. The apparatus is arranged as shown in figure and current is passed through the electric bell. The entire apparatus is kept on a vacuum pump. When current is passed, the electric bell starts ringing, and from the transparent bell jar we could see the hammer is hitting the gong. Slowly, the air pressure inside the bell jar is reduced by pumping out the air through the vacuum pump. As the air in the jar is being pumped out, the sound becomes fainter, although it is the same current that is passing through the bell, and the hammer of the bell is hitting the gong with same intensity. On reducing the air pressure further, the intensity of sound reduces, and at one point we will not be able to listen to any sound, although we will see the hammer hitting the gong. When air is allowed to enter the glass bell jar, again sound is heard. This proves that sound needs a material medium for its propagation. This experiment can be seen by simulation in the given link of OLabs. Let us differentiate between longitudinal wave and transverse wave. Longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction of propagation of wave. On the other hand, a transverse wave is a wave in which particles of the medium move in a direction perpendicular to the direction of propagation of wave. Longitudinal wave needs a material medium for its propagation. As sound is a longitudinal wave, it cannot propagate without any material medium, cannot propagate through vacuum. On the other hand, transverse wave can propagate without a material medium, and it can propagate through vacuum. Light wave is a transverse wave. That is why light from sun can reach to the surface of earth, although there is vacuum in between. Example of longitudinal wave is a slinky when it is stretched out in a horizontal direction across the classroom, and a pulse is introduced into the slinky on the left end by vibrating the first coil left and right. On the other hand, in the same slinky when it is stretched out in horizontal direction and the pulse is introduced into the slinky on the left end by vibrating the first coil up and down. So when it is vibrated up and down, the vibration is perpendicular to the direction of propagation. So it produces transverse wave. A longitudinal wave is characterized by compression and rarefaction. What are compression and rarefaction we will be learning in the next slide. And transverse wave is characterized by crest and trough. The previous slide we have learned the difference between longitudinal wave and transverse wave. Here I have provided one link. If you copy and paste the link in a browser, you will experience an animation which will give you a feel of longitudinal wave and transverse wave. You will see that in longitudinal wave, the propagation of wave and the vibration of the particles are along same direction, and in case of transverse wave, they are perpendicular to each other. Sound wave propagate. A sound wave traveling through air is a classic example of longitudinal wave. As a sound wave moves from the lips of a speaker to the ear of the listener, particles of air vibrate back and forth in the same direction and opposite direction of energy transport. Each individual particle pushes on its neighboring particle so as to push it forward. Remember, the particles of air vibrate remaining in same position. The air molecules does not move from the source of sound to the receiver of sound. Rather, the vibration, the disturbance moves The collision of one particle with its neighbor serves to restore particle 1 to its original position and displace the next particle, particle 2, in forward direction. This back and forth motion of the particles in the direction of energy transport creates regions within the medium where the particles are pressed together and the other regions where the particles are sprayed apart. Region of high pressure is called compression and region of low pressure is called rarefaction. Longitudinal waves can always be quickly identified by the presence of such compressed and rarefied region. This process continues along the chain of particles until the sound wave reaches the ear of the listener. The entire process is shown by the figure below. Here is one critical thinking question on sound. Let us take a long thread. Place your hands over your ears and get one of your friends to place this thread around your head and hands. Then you ask her to make the thread taut and hold its ends with one hand. Now ask her to draw her fingers and thumb tightly along the thread as it is shown in figure. Will you be able to hear a rolling sound like that of a thunder? This activity will be repeated and you call one more person to stand near both of you. Can he hear the sound? Explain your answer with proper scientific reason.